Okay, so to stop us having to write these instructions time and time again to do the same sort of things, what we can do instead is wrap up a set of instructions into something called a function. And then every time we want to do those things, we can just say, run that function. Okay, so a function takes some inputs. It doesn't have to. You can have a function that takes no inputs whatsoever. You could have a function that just says, give me the current time, and it prints that out for you or something like that. But if it's got some inputs, it'll do something with them, and then it'll return an output. And again, function doesn't have to return an output, but most will. And the things that it's doing within the body of the function are just sets of instructions. So it's just bits of code that we can say, do you know what? That set of things that I want to do, let's call it this. And then whenever I want to do that stuff, I'll just say, do this, and here's the inputs, give me the output for that. So a function is defined by giving it a name, so we can refer to it later. The list of inputs it should expect, if any, the things we want it to do, obviously the instructions, and the outputs it should return, if any. And note the use of the word return, that's important. That's how we describe a function providing an output back. It's known as returning. Now, it's also important to state that when you write a function and you define that function, it doesn't do anything until it's called. So we can write a function that, I don't know, adds up 3 numbers. We can write that in our code, but the code won't do anything with it. It'll just say, okay, I now know that function that I've called, I don't know, add up 3 numbers. I now know that's what you want me to do when you call that function, but it's not going to do that. It won't carry out the instructions until you tell it to. So let's look at an example. So if we think about functions in pictorial form, we've got some inputs, and we've got the body of the function, which outlines the stuff we want the function to do, the instructions, and then our outputs. So let's say we've got a function that we want to write called find minimum, which takes 3 inputs, 3 numbers. And what we want our function to do is to find the minimum value of those 3 values, the lowest number that we give it. So we may have 3 inputs, x, y, and z. And then when we call this function, we'd say find minimum, we'd give it 3 numbers. And what our instructions would do is it might say, okay, well, first of all, I'll set the, I'll have a variable called lowest, which will store my current lowest value. And I'll make that the first number by default. And then what I'll do is I'll check the second number and I'll see if it's lower than the first number. And if it is, then I'll set the value of my lowest variable to this new number, because that's lower than my previous lowest. If it's not, then I'll just carry on, because the x value, the first value, is still the lowest one. Then I'll move on to my third value, z. Is that lower than my current lowest? If it is, I'll update my lowest variable value to z. If it isn't, I'll keep it to what it was before. Once I've gone through those instructions, I'll then return the value of the lowest variable. So the value of lowest will then be our output from this function. So if I called that function as find minimum, and I gave it the 3 inputs in brackets there, so the numbers 3, 7, and 2, that function would run, and it would return the value 2. And you'll see when we do this in Python that you can then assign a, because it's providing an output, it's returning a value, we then use a variable declaration. So we could say minimum value equals find minimum, and then whatever function, whatever lowest number comes out of this function, that will be returned, and that will then be stored in this variable value. That'll all become clear when we actually do some hands-on coding. But the key things to remember are: you give a function a name, you give it a set of inputs, you give it instructions to carry out when it's called, which, if it's got some inputs, will do something with those inputs, and then it returns 1 or more outputs, or in some cases no outputs, but that is rare. Coupled alongside this is something known as object-oriented programming. So far, we've talked about programming using something called procedural programming. Now, procedural programming is the old-fashioned way of doing things. That's basically where we say we write a list of instructions, and we want the computer to go through each of those instructions in turn and carry them out. And so back in the old days, you know, when we were using BASIC and things, we'd literally have line numbers. We'd say, you know, 10 print this, 20 print that, and it would just go through one by one through the sets of instructions and do those things. But in modern times, the better way of programming, if you're doing anything beyond, you know, something fairly simple, is to use what's known as the object-oriented programming framework, or OOP. And in OOP, everything is centered around objects, and each object has its own attributes that describe certain features of the object, and it has certain methods, which are functions. And your objects that are created as instances of classes. And the classes are essentially blueprints for how certain types of objects should work. Now, I realize this probably sounds a bit weird, so I'm going to go through some examples so you can see how this works in action. But the principle is that you have blueprints for something, and then you create an instance of that as an object, and that object holds certain attributes, things like variables that store certain qualities, and methods, functions, which tell it how to do certain things. So let's look at an example. Can anyone tell me what this is? It's not a trick question.
An ambulance.
Yes. Anybody else?
It's a vehicle.
A vehicle.
Vehicle. Yeah. Anybody else?
It's an emergency vehicle, and it's not local.
Yeah, very, very well spotted. It's not one of ours. Yeah, you're all absolutely right. I could say that is an ambulance. I could say it's a vehicle. I could say it's an emergency vehicle. These are all correct statements. Let's think about this in terms of an ambulance and in terms of being a vehicle. What we could say is that, yes, it is an ambulance, but an ambulance is a type of vehicle. Okay, so in object-oriented programming, we would consider a vehicle to be the class. And an ambulance is an example of a vehicle. It's a type of vehicle. So it's an instance or object. So we create from the blueprint of vehicle a particular instance of vehicle called an ambulance. Yeah. So it's an odd way of thinking about things at first, but it makes a lot of sense with programming. So you're thinking, okay, well, an ambulance is essentially an instance, an instantiation of the concept of a vehicle. In the same way that a car is an instance of a vehicle. Okay. So let's look at this. Let's break this down. So let's imagine we had a class called a vehicle. The class contains generalized description or blueprint for that type of object, for that class. Yeah. So and we said that classes contain both attributes and methods. So it might be that our vehicle class contains some attributes such as the common name, so you know, ambulance, car, bike, whatever it might be, and we might store that as a string. We might have an attribute that contains the number of wheels that a vehicle has, which we store as an integer, and the capacity, the number of passengers it carries, and we might store that as an integer. Similarly, we would also have methods for the class. So one method for a vehicle might be to tell it to drive, and the input to that function, we could imagine what an input could be speed. So we could tell the vehicle to drive at this speed. So from that generalized blueprint, we can then create objects. We can create instances.
So that's something that is happening. Yeah, just to put it out there.
Hello, sorry, I think somebody's not on mute. Okay, so we can create instances of this class. So one type of vehicle, one instance of a vehicle, might be an ambulance. Now, when we create an instance of an object, an instance of a class, we create an object, and that process is known as instantiation. It means we create an object from that class. And when we create an object, it inherits all of the attributes and methods from that parent class. So when we create an ambulance, then it automatically grabs all of the attributes. It has a common name, it has a number of wheels, it has a capacity, and it has the method to drive. But we can also add extra attributes or methods to it as well. So let's imagine we've got an ambulance. So this is an instance of the class vehicle. So the common name we would give it would be ambulance. We could say it's got number of wheels 4, and we've got capacity of, well, 3. I mean, that's debatable on an ambulance, quite difficult, but let's just imagine 3. Now we've inherited the method to drive at a certain speed, which all vehicles will have, but an ambulance will also have certain additional methods that not other vehicles might have. Now, fuel refill, some other vehicles will have. So we could have a method that tells it to refill its fuel, and we could have an input to that saying, fill it up to this level. We could have a method that says activate your siren or deactivate your siren, and that's going to be particular to emergency vehicles, for example. We could have, and then we've got things that would only be applicable to an ambulance, things like loading the patient or unloading the patient from the ambulance. Similarly, from that same class, we could have an object called a bicycle. A bicycle is a type of vehicle, but it differs slightly from an ambulance. So in this case, the common name for the bicycle is bicycle. We've got 2 wheels and a capacity of 1. We've still inherited the, I mean, drive is probably the wrong word, but you know what I mean, the drive method. But we've got a method that's unique to bicycle in terms of repair puncture. Similarly, if we wanted to create a car is an instance of the vehicle class. So we've given it common name car, 4 wheels, capacity of 5, and again, it inherits that method of drive, and also the same one as the we gave to the ambulance in terms of refilling the fuel. But we wouldn't put that in the class because obviously there are vehicles such as a bicycle, which we wouldn't refill with fuel. Let's look at another example that's a bit more relevant to our problems. So let's imagine we have a class called patient. Again, that class defines what a patient looks like. And so each patient has a set of attributes and a set of methods. So it may be that our attributes will include things like a name, which we'd store as a string variable, a patient ID, which you might store as an integer, and an age, which we might store as an integer. We'd probably store date of birth, actually, but for the purposes of this. And then we might have some methods that we want all patients to have. We might have a method that says attend ED or receive treatment. And then when we're dealing with particular patients in our model, for example, we would then create an instance of the patient class and create separate objects. So we might have an object representing Bob Jones with patient ID 23195392, who's age 64. Similarly, we might have a separate object for Mary Smith. She's got her own patient ID and age, and the same for Janet Small as well. So each patient is its own object, but it's a type of patient. It's inherited all of these things from the patient class. Does that all make sense so far? Are there any questions about any of that? No? Good. So this will make much more sense as you start to code as well, but just trying to get into your head this idea of classes which contain the kind of blueprint for what a vehicle might look like, for that general type of thing. Trees is another good example. You can have a class called tree, and then various instances, the objects which represent different specific trees. So your objects represent specific examples of a class.
Dan, there is a question there from Greg Page. He said, can you get hierarchical classes, e.g. class vehicle, class car, class sports car, object, and then is there like Robin? So.
Yeah, we'll come on to more details about sort of inheritance when we go into the trade. So yeah, we will sort of cover that kind of thing. But yes is the short answer.
Right.
So that's sort of classes. Now, when we create or instantiate an object from a class, we need to tell the computer what to do. And the way in which we do this is using a method which all objects will have, all classes will have, called a constructor. And the constructor will essentially define how this object should be assembled from that class. So what it does is, let's say if we take the example of the vehicle one here, as well as the drive method we've got listed there, there will also always be a constructor method. And in Python, as you'll see when we come on to object-oriented programming in a few weeks, you'll see that's preceded and followed by a double underscore, and it uses the word init for initialize. That method is your constructor. What that does, so in the case of vehicle, let's say we want to create an ambulance, what it'll do is it'll specify the default values for the attributes. So if we're creating an ambulance, it'll give it the values ambulance, or common name, number of wheels for, etc. And it'll essentially just determine how this object is set up at first pass. Now, some of those values may change. So some of those initial values will change during the program, but it will essentially construct that from the ground up and say, this is a new object. These are the default values for its attributes, and these are the methods that we want for that particular object, which, as we've already seen, may just be, so the case of patient, we just inherited those two methods that we had from the class, but in the case of vehicles, we actually wanted to, in some cases, add extra methods beyond the drive method. So in the constructor, we can say, and also give it this method as well. Okay, so now we've talked about functions, and now we've talked about object-oriented programming. Let's imagine that you have been asked to ensure that your code for the cash grab shower system is object-oriented. So what I want you to do in your groups, you'll actually have 35 minutes till 10 past, to draw up some diagrams which show the classes that you think you'd include for that system, along with the attributes for those classes, including their type, and the methods you think would be needed for each class. And what you should also do is include a short single sentence description of what each attribute and each method does, and prefix those with a little hashtag, which, if you've not done programming before, will become clear when we start coding next week. So here's an example from the vehicle example here. So I've drawn out a box here that says class vehicle. I've listed down the attributes, which in this case was common name, which is a string, number of wheels, which is an integer, capacity, which is an integer, and the methods that I want. And then alongside that, I've then placed, using hashtags, little descriptions of what each of those things do. So common name stores a string representing the name of the vehicle type. Number of wheels stores an integer that stores the number of wheels on a vehicle. Capacity stores an integer that represents the passenger carrying capacity of the vehicle. And the drive method tells the vehicle to begin driving at the speed given as an input to the method. So I want you to do that, draw up those boxes and those hashtag comments for all of the classes that you think you would need to represent the cash grab system described in exercise 1 in an object-oriented program. And I want to see what you come up with. So again, work in your groups, and then we'll come back at 10 past 4, and I'll get you somebody from each group to present what you think should be an object-oriented structure for this. So any questions about any of that? Great.
There
Fantastic.
is one.
Oh, sorry,
There's
Bob.
one on there. Do you have to add all the data separately for objects like patient name and number, or can this be pulled from another system?
So that would depend on how you've set up your your program. So I mean, I give that as an example here. Usually you would pull that in from a separate, you wouldn't have your data hard coded in your program. That would be pulled in from a separate data source. But when you're dealing with an individual patient, you would, if you're dealing with patients as objects, you would pull in that data to create that patient. Yeah. Any other questions on that? No? Great. Fantastic. If you get stuck, give us a shout. We will hover in and out of your sessions as we did before. So please ignore us unless you need us. But otherwise, see you at 4:10. Thanks very much.